Hello everyone, welcome to this afternoon's webinar, and we're going to be looking at BIM software. Thank you again for coming over. So let's see what we've got today. We're going to be reviewing various bits and pieces regarding the BIM issue that's big and hot at the moment. We're going to have a BIM overview in our agenda here. Then we'll explore, what are some of the driving factors behind BIM? And we'll have a move on to have a look at a brief review of some of the Autodesk software that can help you implement BIM. Then we'll move on to a short Revit demonstration to illustrate some of the advantages of 3D over 2D and how to get that building information out with schedules that provide up-to-date lists of, well, just about anything really, and can help support your BIM process. After we've looked at building information, we'll then go on and look at some of the purchasing routes for BIM software as well. We have a good amount to discover over the next hour or so, let's get started. Firstly, BIM, B-I-M. What's it all about? What does it stand for and why is it important? When talking about BIM, you'll find that you're going to be seeing a lot of TLAs. In other words, three-letter acronyms. So, in a nutshell, the first of those TLAs is BIM itself, Building Information Modeling. That is, models of buildings that have got information. It's straightforward. Another one is PASS, specifically PASS 1192. Okay, what is PASS 1192? Basically, PASS 1192 Part 2, this is the new BIM standard. PASS stands for Publicly Available Specification. Okay, publicly available specification. And this is a fast-track industry standard, and whilst it is actually published by the British Standards Institute, it isn't a British standard, but it does reflect what is considered best practice. Okay. There's a whole host of other TLAs. We have things like CDE. This is all about the common data environment. When you embark on employing a BIM process within your firm for any particular project, what needs to be agreed amongst all of the collaborators on that job is a common data environment. What kind of file formats are we going to be using? What's going to be the common way that we're going to share our information? And then on top of that, we have PIM, Project Information Model. Basically says what it does on the tin. Another one you'll find is TIDP. Okay, that is for, and that stands for Task Information Delivery Plan. And then another one is a good example, LOD or LOD. Basically, this is talking about level of detail and level of development. Now, all of these terminology that we're going to get, buzzwords are going to be thrown around. You're going to find good explanations in the various documents, such as the PASS document. And also, a really good resource for BIM is going to be the NBS website. So I recommend that you do go along to the nbs.com website, and in there's all sorts of toolkits that can help us understand in more detail about the BIM process. So what is actually driving BIM? Way back in 2007, the Chief Construction Advisor, Paul Morrell, he advised or introduced the government mandate for BIM for centrally funded government projects. So this is not really a recent development. It's been brewing for quite some time. There will be a phased rollout with a view to getting all appropriate projects onto 3D collaborative environment by March 2016. Okay, so let me just repeat that. There's going to be a phased rollout, and the basic aim here is that all government-funded projects will need to be delivered in a 3D collaborative environment by March of 2016. Now, there's a summary action plan attached to the government construction strategy. Okay, and this contains a detailed implementation plan for building information modeling, and there's plenty of additional publications that illustrate in depth the intent of the government strategy. So we've got the Cabinet Office form there, and one which is the actual BIM form. Now, with this whole concept, the key aspect is that at our early announcement was that we need to embrace more software. Well, obviously, we're all using CAD, so that's not a big surprise. But we need to take it to another level to capture and control information about our buildings. Now, at a base level, this could have just been the inclusion of data in a spreadsheet, such as Excel. This base entry point, it fits into the description of BIM level 1. Okay, now these BIM levels, we'll discuss those a little bit later. Now, the reason for organizing our data is to have it in a structured content that aids collaborative working. So all the information can be passed from one party to another party, and it's in the same format. All the fields, the way it's organized, it's common, and that means people can start manipulating it and sharing it and bringing it into their own systems, because the mapping of that information from one system to another, it will just work. And so we can get the reuse of this data. So what are these levels of BIM? Here's a graph. I expect many of you have seen it quite a few times before. It depicts the levels of BIM in various stages, from basically pre-BIM through to level 3. As we can see in the charts, pre-BIM, or level 0, was basically when we were just doing drawings, and it was just CAD, lines, arcs, text, that kind of thing. And we just issue out the drawings, possibly just printed, and that was it. And the information was very insular. It couldn't do much more than present what was on the page. We then, of course, started moving over to having 3D information as well, and CAD standards started to be introduced. So let's look at this in a little bit more detail. Now, the government has recognized that the process of moving the construction industry to full collaborative working will be progressive, with distinct and recognizable milestones being defined within that process, and they're doing that in the form of levels. And these have been defined within the range from 0 to 3. And whilst there is some debate as to what these 3 levels actually mean, the broad concept is as follows. So let's go through these. Level 0 BIM. In its simplest form, level 0 effectively means no collaboration. 2D drafting only is utilized mainly for production information, similar to the level of information you get at the REBA Plan of Work 2013 Stage 4. Output and distribution is via paper prints or electronic prints, or a mixture of both. Now, the majority of industry these days is well ahead of this level 0 by now, so we're all heading in the right direction. Level 1 BIM. This typically comprises of a mixture of 3D CAD for concept and 2D for drafting, and of statutory approval documents and production information. Often with it, that will be the CAD standards will be managed to BS 1192 2007, and the electronic sharing of data is carried out in a form of common data environment. That's that CDE I mentioned earlier, a common data environment, and this will be typically managed by the lead contractor. This level 1, this is the level at which many organizations are currently operating. Although there is no collaboration, or very little collaboration, between the different disciplines, and each publishes and maintains its own data in isolation. That's level 1. Now for March next year, the target is to get to this level 2. So what does that mean? This is distinguished by collaborative working. All parties use their own 3D models, but not necessarily on a single shared model. The collaboration comes in the form of how the information is exchanged between different parties. And the crucial aspect of this level is how the information is exchanged. Design information is shared through a common file format, which enables organizations to combine that data with their own data in order to make what we call a federated model. Okay, and once you have your federated model, so we've got architectural details, structural details, services details, all in the same place, we can then carry out and start and doing interrogative checks on it. Hence, any CAD software that each party use must be capable of exporting to one of the common file formats. An industry standard, broad standard, could include the IFC standard. That's Industry Foundation Class. IFC, Industry Foundation Class. And coupled with that, it could be that we're using the COBie standard for getting that information out as well. COBie, that stands for Construction, Operations, Building Information Exchange. Okay, COBie. And this is the method of working that has been set as a minimum target by the UK government for all work on public sector buildings by 2016. Okay, so it's important to understand a little bit more about this COBie and become familiar with IFC files for data exchange. Level 3. Okay, level 3 BIM. It's currently seen as the Holy Grail. Okay, this represents full collaboration between all disciplines. That means using a single shared project model which is held in a centralized repository. Yeah. All parties can access and modify that model. Okay, and then the benefit of that is that it removes that final layer of risk for conflicting information. Now, this whole concept, this level 3 concept, is known as Open BIM. Now, the target, the UK government target for public sector working at level 3 is going to be 2019. So it's a little way off yet. So they're being fairly realistic about this. And of course, there's a lot of nervousness in the industry about this. around such issues as copyright and liability. Now these are intended to be resolved by the means of robust appointments of documentation and software, with originator being clearly defined, read and write permissions being defined, and also the latter by shared risk procurement routes such as partnering. Okay, so it's a little way off yet, and there are some issues that have still got to be resolved. And the CIC BIM protocol, it's another TLA for you to look up, the CIC BIM protocol, it is making provision for these issues. So obviously that's an ongoing development, but that's what we need to look out for. So here we have the levels of BIM. Most people are at 1. The aim is to get to 2 for the immediate future. And with this collaborative working, looking ahead, it's highly probable that collaborative working practices will ultimately filter through to the private sector. Okay, BIM documentation. How do we deal with this? What's expected? What's the expectations? The BIM process and the COBie tools work well within the REBA protocols, and these have been updated from the old drop points to a revised set of stages numbered 1 through to 7. Here we have the stages, and this is based on the REBA plan of work. We can see that there are a slightly increased number of stages regarding the spread of time. Okay, and the reason for this is all about getting a greater level of detail in the design and in the collaboration. Stages 3 to 4 are expanded, and this is to include the opportunity of collaboration between the different construction industries, where even before construction starts, clashes between services, structural elements, analysis for lighting and heating can be performed. So in this area here, where we start making sure before we even get to construction, every aspect of the design has been confirmed. There won't be any clashes on site, ideally. So we're looking at finally digital prototyping coming to the architectural world, and hopefully one day snagging lists and on-site bodging are a thing of the past. We can hope. Now the graph that we're looking at here is a simplified version of the REBA plan of work, and a quick search on the web should provide you with a version in much greater detail, as we can see here. The various REBA levels do reflect the design and build process. The BIM process is all about this and more. The early thoughts about BIM was that it was a cradle-to-grave philosophy, from concept design through to build to the final demolition, cradle to grave. More recent thinking is that the BIM process is cradle to cradle, as buildings are developed and repurposed over time. Now, with that in mind, some practices are developing their businesses to include the ongoing maintenance, FM, of those buildings, because after all, who knows more about those buildings than the designers who have got the 3D models with all the information about that building. They know how they're built, what the construction is, what kind of equipment is in there, what kind of plant equipment, what the heating systems are, what the lighting requirements are to make it all happen. And of course those people with all that information are also the ideal people for doing the refurbishment work as well, because you've got all the information already. So there's opportunities here that we can go through from construction, logistics, operational and maintenance onto renovation, because that gives you a very long-term business, obviously. Autodesk Software for BIM. BIM in a box. There is a general misconception that BIM is a piece of software. It's not. BIM is a process. However, it is a process that is ideally suited to software. So if you're looking for BIM in a box, Autodesk has got the answer with its design suites. Autodesk has got, as you're probably well aware, Autodesk has got a range of software to help just about every design industry there is. Okay, and these are available currently, some independently and others as part of complementary suites. So here we can see there's a whole range of architectural packages, construction packages, MEP, that's the mechanical, electrical and piping engineering, and also structural software as well. So depending which of these categories that you concentrate in, there's a piece of software just for you, and all of them can start sharing that information, and you can refer and bring in models from one industry into another and start doing the clash detection and look at any issues before you get to site. So with the design suites, there are various levels. There's standard, premium, and ultimate. So you need to choose, and if you discuss with us what your requirements are, obviously we can help you decide what's going to be the best design suite for you. Okay, but once you've got one of these, the idea is that you can plan, design and build your projects and keep control of them. Now with all of these packages, you get a huge amount of interpretability, that's easy to say, between the various products. Now on top of that, there are also some additional specific 360 products that help you share information out into the field as well, and we'll take a quick look at some of those a bit shortly. Now the main program that we're going to be looking at, of course, here is going to be Autodesk Revit, the architectural package that also includes tools, powerful tools for the MEP and the structural people. Now Revit is a powerful parametric building system, and on top of that you can actually add lots of different packages from the Autodesk Exchange. This is Autodesk's App Store. In here you can search through, and there's all sorts of different add-on bolt-on packages that you can get for your Revit. Some are completely free, some are like try before you buy, and there's some additional ones that are available to you as what we call a subscription benefit. And the bolt-ons are supplied by either Autodesk or other independent suppliers and organizations. Even here at Graitec, we've been developing software to customize the Autodesk products for many years, and there's a package that we've just recently launched, which is called the Advanced Power Pack for Revit. Okay, and it provides a unique set of tools. that can bolt on and you can access via your Revit 2016. But what about other BIM tools? What else have we got available as well? COBie. Okay, I mentioned this earlier. COBie is a key organizational technique or tool to help with getting information in a format where it can be shared effectively and efficiently. Okay, COBie stands for is the Construction Operational Information Exchange, and it's designed to help organize the design process, design data, and also of the handover of information on completion of the project to the new owners when the building maintenance and life cycle begins. Now the COBie system the intention is here to replace a pile of drawings and PDFs that building owners were given previously with a set of real current data that can be transferred into their own asset and facility management systems. This provides them with a level of data that is more than just a record of the building, but data that can be used for business case studies to see how spaces are being used and explore what the carbon footprint is and many other aspects. With all that information in there, things can start to be scheduled, and obviously your maintenance schedules can be looked at. You know what kind of equipment is, because the equipment that's been specified, it can have in there as part of its information what its maintenance cycles are, and that can all be then passed out to a scheduling system. Now you can get more information about the COBie, general idea and concept behind COBie from the BIM task group .org. Okay, and in addition to that, Autodesk have embraced the COBie approach, and they've helped us to so that we can deliver a BIM package, and it has a toolkit for Revit. Okay, so there's a COBie toolkit for Revit. Currently it's available up to version 2015. I'm sure 2016 will be coming in very shortly. And this is a plug-in tool, so you've got to have full Revit. If you've got Revit LT, or if you're getting Revit LT, the LTs do not allow to have add-on programs, unfortunately. So you do need to make sure that you've got a full version of Revit so that you can get the COBie toolkit, and that's going to allow you to extract information out and deliver it into what is considered the minimum level of detail required to achieve BIM Level 2. And that's what's required for all government-funded projects as from March of 2016. That's the COBie toolkit. In addition to this, Autodesk directly has a series of additional programs that can help coordinate your design and build needs with their BIM 360 solutions. BIM 360 construction management software enables you to get access to all of your information pretty much anytime, anywhere. So that the project data is available regarding the building throughout the construction life cycle. The BIM 360 products are available across various mobile platforms as well as desktop platforms. Currently they're mostly on iOS, the Apple devices, okay, to start with. I'm sure they'll drift into the other mobile platforms shortly as well. Obviously, you'll need to check your actual app store to see if they're there yet. Autodesk do a huge amount of mobile apps. It's quite startling. A lot of them for private individual use are completely free. So the suite the BIM 360 product suite, let's see what it actually includes. So, looking in more detail here, first of all, we have BIM 360 Glue. Okay, this has received an awful lot of press and coverage. It's a very powerful program. It's a cloud-based BIM management and collaboration product that connects your entire project team and helps streamline the BIM project workflow from pre-construction through to construction execution. Next stage on that is something called 360 Layout. Now, 360 Layout app and the BIM 360 web service, it streamlines the process of creating points, field points, in your project model. So that's really useful for coordination. Then we have the 360 Plan web service for construction contractors, and this allows workers on the ground to view and update your weekly work plan and track commitments in the field. They can do this online or offline. So if you've got a specific schedule of works that have got to be done, when certain materials have got to be delivered, when things have got to be produced and put up on site, and you've got this all streamlined, then the BIM 360 plan is going to help everybody coordinate that information. They can just look the information up and see exactly where each stage of that plan is currently at in real time, or near real time anyway. Then we have the 360 Field. This is another management software, but it's for 2D and 3D environments, and it combines mobile technologies at the construction site with cloud-based collaboration and reporting. So you can actually look at the models in 3D and see where things are supposed to be going. Finally, we have Building Ops. Building Ops is a mobile first building maintenance solution, and it helps generate it helps general contractors to deliver a better handover experience for building owners. Building Ops helps them begin operations on day one and helps them better meet the needs of their mobile workforce. So there's the BIM 360 suite. There's a whole range that you can get of mobile apps and desktop apps that can help you go from, once you've got your design done, let's see about actually getting the building constructed. So if you need to have more information about that, please contact us and we can help you explore these particular tools in a lot more detail. So we can see that the BIM has government-supported initiatives. A lot of lead organizations are embracing it, and companies like Autodesk already have the tools in place to help you make BIM a reality. So let's take a look at the main architectural 3D BIM ready solution. And of course, we're talking about Revit. Autodesk Revit broadly, there are two versions. Okay, we've got Revit LT, the light version, and the full version. Obviously, I'm going to recommend the full version, but there are cost issues with this. Which one's going to be the best for you? Okay, let's have a look. Now, there's a wide range of differences between LT and the full Revit. Let's briefly review the big issues that we have with, or the big differences between Revit and Revit LT. First up, central file capability. What does this mean? Central file capability is a system whereby you store your Revit project, your building project, on a file server somewhere, and multiple people can access different parts of that file, we call work sets, simultaneously. So you can have multiple people working on the same project at the same time. This is called a central file, and it is only available in full-blown Revit. Revit LT doesn't support central file sharing. Okay. Workstation rendering. Okay. Basically, while you're working in 3D, you've got everything knows what its material is, and you can get some really nice images that are rendered to a near photoreal quality out of Revit. If you have full Revit, you can actually do that right there on your workstation. On Revit LT, this feature is not available. However, you can still get rendered views out, but you need to use Autodesk's 360 account, and you render in the cloud. So basically, you have a view, you tell Revit you're going to render it in the cloud. It collects all the resources it requires, uploads them to the Autodesk servers, and then from there they get processed, and 10, 15, 20 minutes later, depending on the size of the image, you receive an email saying your render's ready. Now, there are some advantages to that, because when you are rendering on a machine, that workstation then becomes pretty useless for anything else, because rendering is very resource heavy. Full-blown Revit can also render in the cloud as well. Model in place. Okay, what does this mean? When you're in full Revit, if you need to just create something, model something up, 3D model something up ad hoc, maybe it's to fit in around a particular building aspect. You maybe want to put in a customized desk somewhere, or a reception desk, and you want to fit snugly around the existing geometry, or maybe columns and walls and ceiling heights. Inside of full Revit, right there within the scene, you can start modeling in place. In Revit LT, you don't have this capacity. If you want to create custom components inside of Revit LT, you need to generate them externally in a Revit family. So you then have to, once you've generated that family, you can then bring it back into Revit and position it. And hopefully you've constructed it in such a way that it fits just right. But of course, you lose the advantage of being able to actually reference off of the existing geometry. So sometimes there can be a bit of toing and froing until you get the model just right. MEP, another TLA, mechanical, electrical, and piping services. In the full version of Revit, we have a set of tools that allow us to run services around our building. Ductwork, piping, electrical systems, lighting and circuitry and power, and additionally piping services as well. So hot and cold water, radiators, heating, that kind of thing, MEP. Again, Revit LT does not have these services tools. And if you don't need them, fine. But if you do, you need full-blown Revit. Conceptual massing. Okay, what does this mean? Basically, this offers you the capability to literally create a shape of a building, okay, without necessarily going into the detail about how it's being made, what the construction of it is, and just get the shape of it right. So if you just want to get some idea of how something looks, or perhaps you need to start you want to do some studies of, you want to put in the shape of your proposed new building and just do some massing of neighboring buildings so that you can see how it's going to fit in, then the ability to create a mass model is built into full-blown Revit. Historically, this is the kind of work that would have been done with programs like SketchUp. Now, one of the advantages of doing it inside of Revit with the Revit tools is that Revit knows what it is. Even though it's just a mass, a 3D solid effectively, It happens to know what its overall mass is and what its volume is. And in fact, you can easily add levels to it for where the floors are going to be. And even at that stage, you can start receiving information out of that mass model about what the overall area is. What is the actual floor area of that entire building with the levels that I've put in, but it's still just a mass model. The other advantage of using the conceptual massing tool over the likes of SketchUp is as soon as you click on the side of one of these concept masses, you can say, well, make that a wall, make that a curtain wall, make this an actual floor. What kind of floor? Make that a roof. What kind of roof? And it will just make it for you. If you're using traditionally SketchUp and then you're bringing your SketchUp model in, then what happens is you end up having to effectively use it as a tracing element and you're redrawing everything. So if you transfer your idea of, rather than using SketchUp, do your concept massing inside of Revit, it just leads on to a much smoother and quicker workflow. And Revit LT cannot do conceptual massing. Okay. Stair by Sketch. Okay, this is another tool that is only available in full Revit. There are basically two types of stair tools. One is stair by component, and these are where we've got some standard macro-driven stair design tools. These will allow you to do straight stairs with landings and spiral stairs and circular stairs and winder stairs, and you can just basically say, well, I want it to go from level 0 to level 1. I then want it to repeat right the way through my 5-story building. I want to specify how many steps it has, and it does a pretty good job, to be honest. It really does. However, there's going to be times when you need more of a custom designed stair. Okay, maybe it's a grand staircase and with a lot of flourish on the beginning and curls, and it's going to look very nice. Or maybe you're having to work on a listed building and the staircase simply does not conform to modern standards. In these cases, you need to be able to literally sketch out the shape of your stair, and then Revit will then generate the stair up through the floors that you need it to, with the steps the way that you have drawn them. And this is stair by sketch. And Revit LT doesn't have stair by sketch. I hope that makes sense. Analysis tools. Again, this is another advanced feature only available in the full Revit. And with this, you can start analyzing your building. Check the analytical models, structural loads if you've got structures in there. Look at boundary conditions. Check out heating and cooling loads. Do solar studies. And overall, you can take it into things like Green Studio, where you can then start looking at, what is the carbon footprint impact of this particular building. And finally, the other big one, of course, is add-on capability. We talked a little bit earlier about things like the Kobe tool, add-on tool for Revit. This is a plugin, and only the full version of Revit can have plugins. So in Revit LT, it's just not available, and that's typical or been pretty normal for as long as I can remember. There's always been a difference between the LT products and the full products. LT, you can't have the add-ons. In the full versions, or whatever the software is, it has the API that will allow you to add bolt-on programs. So those are the main differences between LT and the full-blown Revit. What we can see on here are all the items that the full Revit has got that LT does not. There are some other issues, other little bits and pieces as well, but these are the main ones. Okay, demo time. Okay, hopefully you can all see my Revit product right now. So what I'm looking at here is a drawing, and the reason I've actually opened this particular drawing up is primarily just to have a first look at the Kobe add-on. Now we are running here 2015. As I say, the Kobe add-on is only available for 2015 at the moment. I'm sure the 2016 will come in due course. So what you'll see up here is we have a Kobe extension. It's on the add-ins tab. Now, of course, you've got to have full-blown Revit to have this capacity. So we've got the Kobe tools in here. I'm not going to go into a huge amount of detail regarding this, because we could spend half an hour going through how to set up the Kobe extensions. But what effectively happens inside of Revit is everything knows what it is. So, for example, if I pick on this AHU, we can have a look in the properties here, and it knows what its water pressure is, it knows what its water flow is, what the overall air pressure is for it, its construction, its specific size. If we have a further look deeper into the details of any of these items, we can see it has all of its dimensions, it knows what it is, and there are also some additional what we call identity data, where we can add more information as well. Inside of Revit, just as going back a few steps in case you're not too familiar, Revit is a 3D modeling tool, and everything inside of Revit is what we call a family. In other words, it's a very, very smart block. Okay, and that means that all of the information that's required to have and create a BIM model is already built in to Revit. Now you can, in addition to this, add further fields, or what we call parameters, to any of the family items to make sure that you get the information out that you want. Now, with the Kobe extension, once you've got it added in, okay, you just download it, run it, and it just installs itself and it adds it to the add-in. On a particular project, the first thing you would do is you click on Setup, and in here we can see we have some choices to make. First of all, manage your contacts. So anybody that's going to be involved in the project in any way, this is where you'd add your collaborators or other engineers within your team that are going to be involved in any of the design features, design that's required for this particular project. And then we've got settings. So if we click on settings, we get a dialog box that looks like this. So obviously we'd set this to UK standard. Okay, this is all about the Kobe, still Kobe extension, and you can see running along the bottom here, we have a series of tabs to work our way across, where we can start specifying how we want information to look, and which pieces of information that are going to be important to us. Okay, there's type categories, whether it's going to be omni-class, assembly code, uniform map, or whether you want to grab information out of the family's keynote. Okay, secondary priorities and third priorities. So you've got levels of detail, so you can decide which way you want to go. You can decide on the units. Now, either you can override what your present Revit units are. Okay, you can tell it to be in feet and inches, but more likely millimeters or meters, or you can just accept what the Revit standard is. You can decide how you would like it to tell you the area information. Do you want it in square feet or meters, etc.? And similarly, you can make the same decisions regarding the volume. Names. Okay, this is how do we actually recognize different elements inside of our Revit model. Okay, so in here we've got Kobe spaces. Now inside of Revit, we've got two kinds of spaces. We've got spaces, and we've also got room names. As you can see, Revit room or a space, and we can go through here and make decisions as to which of these it is that we're interested in. Okay, is it do we want both? Okay, if you wanted to analyze and get information about both your rooms and your spaces, you'd pop a tick in this little box here, and what will happen is at the end of every individual reference that this system will generate for you, it will put on it'll append the description with either ARC, obviously for it's an architectural detail, or whether it's an MEP detail. So ARC for rooms and MEP for a space. And so you go on, so we can carry on going through and just making decisions about how we want the COBie to interrogate and actually set up parameter information for the report that this can generate that's going to meet the minimum standards for BIM level 2. On the spaces, here we can decide what kind of space we're interested in. So you can see here air terminals is definitely going to be a space, it won't be a room. There's a lot of standards and defaults that have been set up dependent upon the kind of area that you're dealing with. So those items that you can see in this list that are highlighted in red, that's what you're going to get. We have some options over here to say, well, I've only got rooms, I've only added rooms to my Revit model, so just make everything a room, ignore anything else. Or maybe you know that it's a strict MEP model and all you're going to be interested in are the spaces. Or of course, you know that it's a mixture of both. Now you can individually just go around and customize these yourself, so you can redefine exactly what the information is and how it should read it. Attributes information, so it gets fairly deep here, and once you've ticked something, you'll see that you can also drill down and decide on some very deep information about all of the components and the elements and the build and the wall build-ups and the condition, the features inside of your Revit model. Coordinates, that's just about how you want the coordinates to be, so that's straightforward. And schedules. So this is the important one. What information do you want with a particular schedule? Is it going to be doors, windows? Is it going to be multi-category? Okay. COBie spaces and systems. Okay. Do you want rooms and spaces or just one or the other? And then you go through and you finalize everything. Now, once you've finalized and you've gone through and made these settings, you can either just do save, and that will save the COBie settings in this particular project. Or if you think all of the settings that you've got are going to be useful for other projects in the future, then you can choose the save and export feature as well. And then finally you finish it. And then what you would actually find is that in the schedules, when you actually generate a Revit schedule, apart from the basic schedules that you have, there's going to be a whole new set of parameters that are going to be available. They're going to be based on the COBie standards. So this plugin is really incredibly useful for those of us that are using full Revit. Okay. So that was probably a bit deep and heavy, but it is just, hopefully it just gives you a bit of an overview. And as you can see, there's a logical process, and it means that you can start extracting information out in BIM Level 2 compliant format, just using this plugin. Hopefully the 2016 version will come out soon. So I'm just going to say no to that one and close it. There we go. Right, I'm just going to switch over now to Revit 2016. Here we go. Okay, so here's a building. This is a typical building, obviously an office building, and we can see that it has all sorts of other features in here. So why is this better than 2D? Or why is it easier than 2D? I'm going to have a very simple look at an area. Let's take a look at, let's have a look, floor 2. There we go. So here we have a simple room layout. Now, as far as a 2D package goes, these are just, obviously all of this is just line work. And it's fairly dumb line work at that. But inside of Revit, everything knows what it is. Okay, and when it comes to drawing, it makes it very, very easy and quick. Even if I was just doing basic, if my final output was only ever going to be a 2D drawing of a building plan, I'd still want to use Revit over a 2D program. I'd never want to go back. Let's see why. Okay, you can click on the wall command, and we can then decide how we want to draw it. We have a whole selection of drawing tools on this drawing panel here, so lines, rectangles, arcs, circles, sort of things I'm sure that you recognize. But more than that, we can also tell it how high we want these walls to go. So I've got a height option here, and I'm going to tell it how high I'd like it to go. I'm on floor 2, so I want it to just to go up 1 flight, so that's going to go to floor 3. And then over here in the properties area, this is where you can see that we have a huge variety of walls, and we can choose any of these particular walls. Although a quick tip here is, because I want to do a series of walls that are going to be the same kind of walls as these, I'm going to pick an existing wall, right click the mouse and go, hey, create similar. There we go. So then I could simply draw a line in here. You can see I can get some information, get some feedback. I can decide how big it is. I could say, right, I want this to be 3,000. Now, so there's 3 meters, and plug it in. Or I can do another one here. I want this also to be 3 meters, so I could just actually type 3M. There we go. I'll bring it over here. I'm going to put a little cupboard area into here. I can see this is probably a little bit too deep. I only want it to be 500, so I just change it as simply as that. And as you can see, when it comes to just drawing, all of these walls, it's cleaned these up. It's made these connections very, very simply. How about doors? Let's have a look at doors. So I'm going to put some doors in. Okay. Got various doors available, so I can choose whichever door I feel is going to be useful at this time. So we'll go for one of these, and then literally you bring it to the wall where you'd like it to be placed, decide which side you'd like it on, and you can decide which way round it's going to open. And I'm going to say that I'd like this to be right about here and about 100 millimeters away, just like so. There we go. Put another door in right here, and I want this at a midpoint, and Revit has found the midpoint very easily for me. If you look at the temporary dimensions that we have there, we've got, it says 102.4.3, 102.4.3. So we'll have one in there. It just gets on with it. I'm going to use a different door now, so I'd like a bifold door. So I'm going to choose a bifold door. Here we are. Boom. And this one's going to go right in here. And look at that. It just cuts it out. All the information, all the walls, it's just simply been cut out. And it's done. So drawing with this is just so easy. Now this particular design that we've got here, I want to repeat this over here so I can very simply select all those components. Now, oops, it looks as though I've got these columns as well. Now I don't want to copy those. So one of the nice things here is that I can just filter out what I don't want and keep what I do want. So I'm not interested in structural columns, I'm just interested in those doors and those walls. Okay, so that's all I have. Terrific. I can just use a basic copy command if you're used to AutoCAD or similar. You may recognize a lot of these commands up here. Yeah, very straightforward. Copy, offset, align, array, move, yeah, rotate. So I can simply take this, take a point from here, and bring it to there. Very simple. In addition to that, I could now decide, well, actually, I want this same layout in this room here, but the other way round. So I'm just going to use the mirror tool and pick there. And there we have it. It just takes care of it. It's very easy, very simple to do, very fast. Now, in addition to this, everything knows what it is. Okay, if I pick on this wall, we can see that this is an interior wall. It's got a partition in there. It knows what, exactly how it looks. Now, in addition to this, at the moment, this is a fairly coarse level of detail. There's not a lot of information going on here that we can see. You notice we've got, it's 1 to 100. If I was making this a 1 to 50, it could be that I might want to increase what we call the level of detail. And I could take it up to a fine level of detail. And as we zoom in on here now, we can see all of the different aspects to the makeup of those walls. So very simply, I've been able, at a click of a button, I've been able to go from what was a construction approval plan to a construction plan, simply by clicking a button. Very, very simple. In addition to this, if I wanted to, I could have this in shaded mode, but we won't bother with that, not in a plan. But we have all sorts of visual aids so we can change how things look. I'm going to return that back to hidden line. Okay, I'm also going to change this back down to a coarse level of detail. Now, these doors know what they are. If I pick on it, if we look over in the properties area over here, you see it says mark 421. This is its door number. Okay, this is its door number. And this one here, oh, that's 422, and this one's 423. They have automatically numbered themselves for me. Okay, they're completely changeable. So if I wanted this actually to say, well, actually, this is going to be 2-242. It's as simple as that. You can just rename it. And similarly, all of these doors that we've then copied, what are they going to be? This is it going to be the same because I've copied it? Let's find out. 424, 425, this one over here, that was 422. No, as soon as you start copying this common data, Revit figures it out and goes, more doors, let's renumber them, continue the numbering in the sequence that it is currently in. And it just gets on and does it. Now, of course, you want door tags on here. Basically, we can go up to the annotate ribbon here, and we've got a whole load of tagging tools. And I can simply say, I want to tag this door here, put a room tag on it, and there it is. I can move it over here if I want it on the outside. And I could do another one. Boom. Simple as that. Now, if you've got a lot that you want to do, why not, and you want to tag them all, why not tag them all with the Tag All button? Okay. This dialog pops up, and you can basically decide which kind of objects within this particular view you'd like to put the identifying tag against. In this case, I want door tags, and yes, I'd like a leader on them. The length of the leader will be 6 millimeters. I can say apply. Done. There we go. Straightforward as that. Now, how well does it really know this information? This wall here, we've got a description of it, but what's it actually like? If we click on it, we can see there seems to be a nice icon here indicating what it looks like. But if we go to this area here and to go and have a look at the type properties for it, and we click on where it says structure. Okay, so find where it says structure, and there's an edit button next to it. Boom, hit that, and there we go. Here is all of the build-up of that wall. It really does know exactly what it is, what the function of each part of this structured wall is, what the material is, how thick it actually is. And when you look at some of these aspects a bit deeper, okay, this is common brick. What is that brick? You know, what does it look like? And what are its physical and thermal properties? Here we can see the density of it. And also, what are its thermal properties? So once you start building up and you're thinking you're just putting down, well, lines that represent walls, it is far more than that in Revit. It's BIM built in. It really is. And all of this means that not only can you just export this information, this is where we can start using these tools on this Analyze tab up here as well, so that we can actually start figuring out, well, how much heating is it going to need? You know, how much cooling is it going to need? You know, depending on which part of the world it's going to be in. So your Revit model is ready-made, but of course, all of this information can be added to and changed and amended as you need it. And of course, one of the great things about this is while we're drawing away here and it appears we're just doing it in 2D, of course, we're actually doing it in 3D. And when it comes to those pesky sections that take so long to do, if I want to do a section, I can literally use a section tool through here. It's going to zoom out a bit. I'll narrow the depth of this. I only need a section that's going to be that big, like so. Let's have a look at what we've done. And there's the section. Okay, there's the section. Again, we could shade it should we wish to. Get an idea about how it's actually going to look. Maybe you don't want to see all of this. Maybe you just want to see a portion of it. Or perhaps you want to see the ground floor, but all of the rest of these rooms are the same going up through this area here. So I'll take a piece out. We'll show just the roof. We'll show the ground floor detail here. Bring those views together. And there you have a nice collapsed wall detail. And Revit comes with a whole host of additional detailing tools that will help you add further detail to this. So if you just want to add some 2D detail to clean up some of the information that we've got in here, it provides it for us. Back in our plan, of course, we've got all of these doors in here, and one of the great tools that we have is we can always generate new schedules here. Okay, so when you click on schedules, you can choose what it is you want to actually get information out and put it onto a schedule. We can choose what kind of information we're interested in, whether it's just architectural or whether we're also looking to extract structural, mechanical, electrical or piping information. You can simply choose a category. So I could say, right, let's have a look at what the doors are. How many of the doors have we got? And of course, they'll always be up to date. So very, very simply, we've already got a schedule made. So I'll have a look here. This is the door schedule for the first floor, and it looks like this. So, and you've got all of the mark information in here. widths, sizes, but you could get much more as well. Frame type, material type, if it's coming, what the fire rating is, and all of this can be scheduled, and all of this information can be extracted out into the COBie format as well. Well, this is about a whistle-stop tour of Revit. There is so much more that it can do, but when it comes to architectural drawing, it really is a bit of a no-brainer. It's so easy, it's so quick, and as some people have said, it's going to get 80% of your drawing work done in 20 to 30% of the time. I've had people on my courses, and their colleagues have told them this. It's such a good product. Okay, we have to move on now. Hopefully that insight into Revit and the fact that everything knows exactly what it is, and with that we've got these add-on tools where we can bring in things like the COBie toolkit has been useful to you. We've got a few more elements that we need to look at now, and so let's move on and have a look at what are the purchasing routes for BIM software. Currently, there are two ways to buy your Autodesk software: perpetual license or desktop subscription. Perpetual license has traditionally been bought in one of two ways. Standalone products. These are the standalone single programs, for example, just AutoCAD, just Revit, etc. And these can be bought as a perpetual license. You buy it and it keeps on working at its current version for as long as you need it in that version. Then we've had design suites. These can also be bought as a perpetual license, and suites contain a range of different products to suit your total design process, from illustration right the way through to construction or fabrication. And finally, we have desktop subscriptions. These are a way to rent the software for a period of time that you need them, and then you decide what to do after the end of that term. And we're going to go into more detail about this a little shortly. The way in which we will own our software in future is changing, and it's only a matter of time. So, probably want to get your notebooks out here. Standalone products, single licenses, will no longer be available from the end of January 2016. Design suites, perpetual licenses, will no longer be available from the end of July 2016. Thereafter, only desktop subscriptions will be available. Also, please be aware that after these cut-off dates, there will be no upgrade or cross-grade opportunities available. Okay, but you're thinking, what about my current perpetual license and upgrading those in the future? Well, the answer is your subscription account. If you maintain your subscription, no gaps, you have an upgrade route. So your big investment in a perpetual license is not lost, but please remember, you must maintain your subscription to get the next version. So if you're currently on 2015 or 16, and you'll then want to move to 26, 17, 18, 19, and so on, you need to maintain your subscription. Otherwise, if you have a gap, your next upgrade will actually be buying, or rather renting, via the desktop subscription route. Yep, this is quite a change from the purchase model we have been used to for such a long time. But as we've seen in so many software industries, software rental is becoming the norm. And let's take a look at how this is going to work with the Autodesk products. One of the reasons why subscriptions become popular from one certain point of view is that for many people, the cost of buying a design suite can be prohibitive, but rental costs are, by comparison, a much lower cost, and it makes it financially easier to have access to the very latest and sophisticated software. And with flexible rentals becoming available, it becomes even easier to accommodate staffing changes as people come or go. Or if you need some extra capacity just for the duration of a project. So if you've got a project, it's going to take 2 or 3 months, you only need to have software for the length of that time. You don't have to have a big outlay and buying a whole new perpetual license. Just rent it for a fairly, in relative terms, low fee, just for the time that you need it. When we are on a desktop subscription, there are several other advantages that we can benefit from, and these include the ability to install our software on multiple machines. More and more employees are increasingly working from locations other than their main office, and the desktop subscription provides the ability to install your software on multiple machines to allow for use in multiple locations. Further than that, some of you are not only needing to work outside of your general office, but also outside of your country. Yeah? And the desktop subscription system can give you global use rights to make it so that you can use it seamlessly abroad as well. Also, just as you want to stay up to date with most of the current software to remain competitive and have all the latest tools, there are lots of cases where having access to previous versions of software is going to be useful as well. If you need, especially with inventors and Revit, and if everybody's working on a 2015 project, everybody needs to be working on a 2015 software. Yeah. So, and with desktop subscription, you have rights to gain access to the previous version, even if you've never previously owned it. So that can be really quite useful, and it makes the life very flexible. Now, desktop subscription includes access to Autodesk's cloud services, and this can help extend your workflow from the desktop to anywhere you have access to the internet, including mobile devices. In addition, each desktop subscription entitles the named user to 25 gigabyte of secure cloud storage. This can be really useful for sharing files, or just if you're having to move, do some work at the office and then go home and do some work, but the file's too big to email to yourself, upload it, and then you can start working it at home. Just download it, job done. Or if you need to share it with clients or other people that need to then start working on their particular area of speciality within a particular building. Additionally, you can enjoy the virtually infinite computing power of the cloud to help you run complex and resource-intensive tasks without tying up your desktop. And with a cloud credit allocation, you can do such things as rendering. Okay, so if you are using rendering and you want to render in the cloud, you don't want to tie up your workstation, or you've just got Revit LT, then you will get your cloud credits so that you can then do your rendering. Okay, let's take a look and see what type of desktop subscriptions we have available. With the desktop subscription, you have got more choices of how you own your software. Okay, there's 4 ways to buy that allow you to choose which subscription is right for you based on your budget and the type of work that you do. Monthly subscription. These are great for freelancers, startups, and very small businesses, or for anyone who needs access to the required software just for the duration of their project. Desktop subscription requires the lowest upfront investment, and it provides the most flexibility. If a project doesn't come in as you were expecting, then obviously you can cancel your subscription by the end of the month. And so you don't have to continue paying for something that isn't going to pay for itself. Next, we've got quarterly subscription options. These are ideal for established companies, whether they're large or small, who often experience seasonal workflow, temporary staff hires, and those ad hoc projects that sometimes come in unexpectedly. The quarterly desktop subscription allows you to easily ramp up or scale down your software dependent upon your requirements. Annual desktop subscriptions. Okay, these are appropriate for those of you, that have got good long-term projects and you need continuous access the entire year through. Larger companies that are working on complex, ongoing projects, may find that the annual desktop subscription is very helpful when they need access to some of the more specialized software that maybe they wouldn't normally buy. But because you're getting it as part of a design suite, you're going to have access to more software at a much reduced price than you would be if you'd actually bought it. So again, it's very, very useful. In addition to that, if you want, you know that you need the software, it also means that if you're still a little bit cautious, maybe it's early days for you, just a single yearly contract may be the way to go. And finally, we have the multi-year desktop subscription. This is ideal for you established companies with a predictable workload over a long period of time. Those multi-year contracts, this kind of desktop subscription can save you money, and it also helps lock in the price for the length of the contract. So you've got controlled spending over a foreseeable length of a project. So it makes it very useful for those larger projects. Desktop subscriptions. So there we have it. This is the future of ownership. And it's not, I'm quite sure that it's going to be in other pieces of software as well, not just Autodesk. And we've already seen it. So hopefully you found this building information modeling introduction useful and picked up a few hints and tips about where you can find out more information. Obviously, please call us if you do need information. So I'd like to just round off with a quick summary of where we are with the building information modeling. BIM basically has the potential to become the information backbone of a whole new industry and take design and facilities management to the next level. Countries around the world are at different stages in implementing this technology, and many governments are backing the program to revolutionize the life cycle of a building. The UK government has started the construction industry on a program that aims to reduce capital costs and the carbon footprint of the built environment by 20%. To see this through, it has stipulated that every new government-funded building project should be BIM compliant by 2016. That's March 2016. Although the UK government is pushing this, many other countries worldwide are also using this process, including the USA, Ireland, Holland, Australia, on many of their developments, thus making it a useful global tool. BIM is a platform that provides contextual information on both building and project development life cycles. A building can be modeled digitally in 3D for clash detection, so that the building design and its functional characteristics can be tested before construction begins. Because of this, risk is significantly reduced within the virtual environment even before getting to site. This process significantly reduces costly design alterations that may not have been previously spotted, further down the line, as well as assisting to achieve project deadlines. And of course, when you can demonstrate your ability to provide BIM Level 2 data packs, tenders for those government-funded building projects will be open to you. So let's all get on board with BIM. That about wraps it up for this presentation. Thank you so much for your time today. These webinars that we've been doing today have been a bit longer than usual, but there has been so much information to try and get into them. I truly hope that it has been a useful use of your time. If you have any questions, thank you, Peter. If you've got any questions, then please put them in the chat here, and I'll be very happy to answer them. Even if it's offline, I can do so. So to learn more about the Autodesk software and other Graitec services, please visit our website, graitec.co.uk, or why not just give us a call on 023 8086 8947. Thank you. As I say, if you've got any questions, you can always give us a call. My name's Greg Benson Shettle, and I'm one of the application engineers here. I do AutoCAD and Revit, obviously. Many thanks for your time and your positive comments. It's much appreciated. Bye for now.